Okay, so if we look at equation 12.5 for textbook, we see that the angle that the shock wave makes will be sine theta, and that's equal to the speed of sound wave divided by the speed of the object. So for our case, the object is the plane. Now the Mach number is given, and we know that the relation between Mach number and our object speed of object and speed of sound is given by this relation, where this is velocity of object over velocity of or speed of the sound wave. Now if we replace the speed of the object, since we don't know that, we know the speed of sound is 310. So if we replace that, we see that the velocity of object is Mach number times the speed of sound. And if we replace it there, we see it's velocity or speed of sound wave over Mach number times speed of sound wave. And then they get cancelled, so we have 1 over 2.1. And if we take inverse, so if we take inverse of sine on both sides, we get sine inverse 1 over 2.1, which is 28.44 degree. Okay, so the second question says that the plane is flying at a height 6,500 meters, and how long after it is directly overhead will the person on the ground hear the shock wave? Now, if we look at this diagram, so let's say the person is standing around here, and what happens is that's the displacement of the plane from the time it passes overhead to the time the shock wave reaches the observer, which is the person right here. So let's see, v object times the time. So this guy is the time it passes overhead. So passes overhead to the time the shock wave reaches to the observer. Shock wave reaches the observer. And since we know the height of the plane to the observer when it's overhead is h, and h is given for our case, we can use simple geometry, and we see that tan theta equals height over base, which is h, over v object times the time. And we need to find out the time from here, because we need to know how long it is directly overhead will a person on the ground hear the shock wave. So our t is h over v object times tan theta. Now we know theta is 28.44 from our previous part, so that's part B. This is part A. So yeah, we know that this is 28.44, and also we know that the velocity of the object is mass times Mach number times speed of sound. So we can replace those numbers over here. So we'll get h over the Mach number times speed of sound times tan theta. And if we now plug in all the numbers, we have 6,500 meters divided by 2.1 times the speed of sound, which is 310 meters per second, and then we have tan 28.44 degree. And when we solve for it, we get a value of 18.44 seconds, and like if we want to approximate it, it's close to 18 seconds.